All right, and we are back, and we are time to look at our chi-squared goodness of fit, and we're going to look at some fast food data sets. So we're going to plot a histogram of the number of calories at Burger King and perform a chi-squared goodness of fit test to determine whether the calories are normally distributed. Then we're going to include that histogram. Then we're going to do another goodness of fit test. This is kind of our more traditional, basically frequencies the same, frequencies different, to determine whether the items at fast food restaurants are equally probable to contain trans fats or not contain trans fats. And then you'll write your materials and methods section. So let's go ahead and let's break down this code. So load our packages. One thing that we're going to add here is this this library environmental stats package. So you may need to do install this package. So just make sure that you do so before, but I'm reading it in because I already have it here. I'm going to set my working directory just as we usually always do. And I'm going to Control-C, paste that in here. And then I'm going to read in my fast food data set. And then we can take a peek at it. And it has restaurants, items, calories, trans fats, non-trans fats, lots of interesting things in this data set that we can work with. So the first thing we were going to do is we said we needed to look at whether let's look back at her. Whether the calories are truly normally distributed for the items at Burger King. So I'm going to filter based on the restaurant's Burger King, and then I'm going to select my calories. So this is going to be my Burger King data set. And again, most of this data set, actually all these data sets are from Tidyverse or Tidy Tuesday, which is a great repository of data sets. So you should definitely take a look at those. So when I look at my BK data, it should just have my calories. So I'm going to do a histogram, and I'm just going to look at it as my x-axis. And I'm going to see, is this normally distributed or not? And to do that, we're going to use this code here that is basically built from this environmental stats package, which is basically saying we're going to take this data set, bkdat, and we are going to test using a chi-square test whether our distribution is normally distributed. And then we're going to kind of set the number of classes. This is kind of a standard, and we're kind of filling in essentially what's our mean, what's our standard deviation, to basically see if it's truly normally distributed. And when we do that, we can see our p-value is what? It's actually greater than our alpha, which kind of makes sense because this looks it looks kind of Gaussian, right? I mean, for the most part, at least at what we're looking at here. So that p-value is greater than alpha, so we are in the do not, basically, or alpha over 2 even, so we are in the do not reject regime. So we do not reject, meaning they are the same. Fantastic. Next, we are going to look at this data set, and we're going to filter when does the trans fats equal to 0, and then we're going to select our restaurant and trans fats, and we're going to count essentially the number of restaurants. So that is going to be what has trans fats. Then we're going to select this. We're going to count essentially restaurant trans fats, and we're going to count essentially because we're seeing here, are we equally probable here? Items at fast food restaurants are to contain trans fats. So we're going to take all the data sets. So that's the total number of items. And so the sum of the items that have trans fats are going to be my total here minus the ones that have trans fats. The ones that have trans fats are already there. And we are going to look at, this is our expected. So trans fats, not trans fats, we're saying they're equally probable. So 0.5, 0.5. We can just do our chi-square test like we've done before in class. And our p-value is much less than our alpha over 2. What does that mean? It means that, no, they're not equally likely. So that is a strong reject. And actually, we can actually look at this data set. We can see this is our, I think, trans fats data. And we can see, actually, what is this? We can see here, looking at just the trans fat data, they don't look, if it was equal, we'd see them all have equal values here. And we see they definitely do not. Like, these aren't 50-50 distributions here. So that's pretty much it. That's our goodness of fit test. And we'll see you next time when we do another goodness of fit test, which is going to be contingency tables. So see you then. Thanks. Bye.